So now we're going to look at expressions that are written exponentially, and we're going to write them in radical form. So let's start with this one, x to the 3/5. So the way that I like to try to remember is it's almost like you're going to walk up to this fraction and you're going to kick the bottom out. So the bottom is the number that's going to go out. So that's going to be our index. And then the other number, the numerator, the 3 in this case, will be our exponent inside. All right, so let's try this one. Remember, we're going to kick the bottom out. Now, this 1/2 is not being applied to the 4. It's only being applied to the x. So the 4 stays as it is. There's nothing that it's being raised to, and it's being multiplied by x to the 1/2. So that 2 in the exponent, in the denominator, is going to get kicked out. And then we have x to the 1st that's left. Now, this is not usually how you would see it written. Normally, we would just see it written like this. Right? Because when there's no number in the index, that means it's implied that it's a 2. And when there's no exponent inside, that means it's implied that it's a 1. All right, in this next one, the 1/3 is being applied to the whole thing. So that means, if I go back to how we did it on the previous screen, right, I'm going to kick the bottom out. That's the number that's going to come out. So I'm going to have an index of 3. And then I'm going to have 8 to the 1st and x to the 2nd. Now that means that I'm finding the cube root of 8 and the cube root of x to the 2nd. Now, I can't find the cube root of x to the 2nd, but 8 does have a cube root. So think about it. Some number times itself, that equals 8. So the cube root of 8 is 2. And then the rest of it is still in the cube root. All right, let's try this next one. For this one now, I have the 9 and the x that are not being raised to any type of exponent, so the 9 and the x stay as they are. Only the y is being raised to the 3/4 power. So remember our rule and kick the bottom out. So that 4 becomes my index number, and then I get y to the 3rd on the inside. All right, 2 more. We've got, in this one, since we have the parentheses, that means this whole expression is being raised to the 3/2. So we kick the bottom out, or we could just write nothing, right, because square root is just like having no number there. And then we have 4x to the 3rd. All right, can we do anything with that? Well, let's take a closer look. This would be the same thing as the square root of 4 to the 3rd and x to the 3rd, right? Because both of these are being raised to the 3rd power. 4 to the 3rd, 4 times 4 is 16. 16 times 4 is 64. So we get the square root of 64x cubed. So that would be simplified, but then there's one more thing we can do because 64 has an integer square root. And the square root of 64 is 8. So we would have 8 times the square root of x cubed. All right, and for the last one, we've got this whole expression raised to the 1/5 power. So we follow our rule and kick the bottom out. That means the 5 comes outside. And we have 32 x squared to the first. So that's the same thing as saying that we have the 5th root of 32 and x squared, right? I don't have to have the 1 there. And 32 does have a 5th root. So it's pretty small, so we're trying to think of some number that equals 32. You can use the key on your calculator that looks like this, and then put 32 in and then hit your 5 for your index. But if you know your multiples, then you'll know that it's 2. So the 5th root of 32 is 2. And then the rest just stays in there. We can't do anything with that.